Hello, everybody. Today we are going to explore a powerful technique that is the cornerstone of modern machine learning, especially in healthcare. It's called in ensemble learning, and it's based on a very simple idea. Teamwork makes the dream work. Uh, by definition, what is ensemble learning? Ensemble learning combines the prediction from multiple machine learning model to make more accurate and robust prediction than individual model. So in a, in a simple example, thinking think of it like getting second opinion in medicine. A single doctor might miss something, but the view of a panel of doctors is much more reliable. So we are doing the same thing, but with a logarithm. So we have multiple machine learning that's gonna help us to make accurate than using one individual models. Why we use this in healthcare? In high-stake field like diagnosis, rely on a single model is risky. So ensemble learning provided a crucial safety net because we are trying to use multiple models. So we try to remove that risk of using one single model. So by explanation of all of this, the core idea is to not rely on a single genius model, but combine several good models. By averaging out the individual error and bias, the collective decision become more accurate and stable. This is critical when predicting patient outcomes. So by doing all of this, by trying multiple models is very critical, especially in predicting patient model, where a single model can result mistake. So trying different model is going to help to remove that mistake. So the first method I'm going to try to explain it called bugging. Bugging, you can say the power of different perspective. So how bugging is work? So in bugging, you train many models in parallel on different random subset of the data. The final prediction is a result of voting if you are dealing with classification model or averaging if you are dealing with regression model. Most of the time here we use random forest. The main benefit of using bugging, so this is the one of the model of doing ensembles learning. So one of the main benefit of this is reducing variance and help to preventing overfitting. For more explanation, this first method. Imagine you have large patient data set. Bugging take random sample of that data and training a separate model on each sample. It's like asking a group of doctor to each review a random selection of patient chart. In the end, they vote to make a final diagnosis. So this process used in popular random forest algorithm is very excellent at making model more stable and less likely to overfitting to the training data. So if you want to put this in a normal situation, it's like you have a group of doctors and you ask every doctor randomly to select a patient chart and to do random review, like everybody do a review in the patient chart, and at the end you vote for final diagnosis. So this is the same when you deal with bugging. You train many models in parallel. in the different random subset, and the final prediction, it depends. If you are dealing with a classification model, you do voting and you get the final prediction. And if you are doing regression models, you are you are getting final prediction by averaging those results. So this is the first method of ensemble learning, and the second one is boosting. So the first one when we look at the first one, we train a model in parallel. But in boosting, we train a model in sequential. So each new model pay extra attention to the instant that previous model got wrong. So you train the first model, you get some stuff wrong, and the second model deal with that what went wrong from the first model. So you do that until you get a good result. So in simple way, it's like a medical student training. They take a test, get some question wrong, and for the next stage, and for the next test, they start those specific topic much harder. So those specific topics, those questions they get wrong, they start harder. That's how it works here. You train the first one, you get some result, you get some stuff wrong. The second one, deal with those stuff. Deal with those stuff went wrong. Main benefit of boosting is reduce bias and often lead to higher accuracy. So for more explanation, boosting take a different approach. It's sequential. You train a first model and it will inevitably make some mistake. The second model is then trained to focus specifically on those mistakes. The third model focus on remaining mistake and so on. So this is step-by-step process of collecting model allow boosting a logarithm like XG boosting to become incredibly accurate. This is why they frequent win machine learning competition. So here, most of the time, we use XG boosting algorithm. So let's look at the final part, conclusion. So why in Ensemble a go-to in healthcare? First one is high accuracy. Ensemble learning, they are champion at finding signal in noise electronic health record, EHR data. So you're gonna get high accuracy when you use ensemble learning. The second one is model boosting. In ensemble learning, it's less sensitive to outlier in training data. So you're gonna get more robust because it's very sensitive, less sensitive to outlier in the training data. The last one is reducing risk. The main opinion approach is safer for critical application like disease prediction or treatment recommendation. So to get more opinion is more stable, especially if you're dealing in a healthcare setting. So this is the last slide. I have this reference 1, 2, 3, and 4. Thank you guys for listening to me. I hope you learned something from this presentation. Thank you.